Hello everybody. Welcome to another installment of North Cascades Highway Geology. Later in the afternoon, you're looking west, now you're looking north. We're swinging around to the east. And a beautiful outcrop here to enjoy, earmarked beautifully by Marley and Darrell's Roadside Geology of Washington book, number 2, episode 2, edition 2, sorry. And I'm right here on the east end of the John Pierce Falls Bridge. If you're looking for a landmark, I'm kind of between Diablo and Ross Lake areas of the highway, and as soon as this large vehicle crosses the bridge, I think we will cross the road, looking both ways, of course. And on my drive today up and over Washington Pass and Rainy Pass, I was carefully following along in Marley's book to make sure I knew when I crossed the Ross Lake Fault Zone. And we have crossed the Ross Lake Fault Zone. So we're on the east side of the Ross Lake Fault Zone, which means we're suddenly into the Skagit Gneiss. An old friend from this summer at Foggy Dew Campground. So I didn't find this hammer, this is mine. And here's Marley's book. So let's read briefly. We try to ignore the traffic noise best we can. And then look at a bunch of hand samples. So I have been tooling my way along on this black line. Washington Pass down here. And then continuing west on State Route 20, and as I just mentioned, I've left the purple, which is the Little Jack terrain, which totally confuses me, so let's ignore it. And I've just crossed into the purple. And look at the extent of all this purple here in the crystalline core of the North Cascades, the Skagit Gneiss. And she's using some terrain names, but I choose to just focus on the rock type itself. So we're about right in here with my pinky, okay? So I guess this is what's here. Now that's a nice photo, but let's actually look at some rocks. Before we do so, here we go. Pierce Falls flows beneath the roadway a half mile east of milepost 133. That's where we are. The road cut displays rock of the banded gneiss, including a lot of deformed pegmatite, screwed up granite with super huge crystals, in other words. Within it are lenses of biotite gneiss, and everything is cut by a series of granitic dikes and sills. A number of researchers have argued that the biotite gneiss originated as a sedimentary rock that was heated to the point of partially melting. There's Diablo Lake nearby. Okay, well, let's not, I mean, come on now, look at this. Look at this stuff. I assume this was just sitting here from a geology stop with some class. So many of these samples are gorgeous, but I guess I'll just grab my hammer and we'll just wander. But I mean, every spot, every sample is just gorgeous. Oh, it's putting up a fight. It's putting up a fight, all right. So I guess you're like, well, I don't know. Does that kind of look like the granite we were looking at? Is this more golden horn? Well, I'm hoping that you can see a coarse mineral size, but I'm certainly hoping that you can see all sorts of foliations. In other words, this is metamorphic rock. It's not that random distribution of large crystals. Instead, there's a fabric or a metamorphic pattern to these rocks. Oh my. Oh my. Wow. I think this is one of those where I'm just showing you a bunch of stuff without commentary, because not my specialty for sure. But this is, I remind you, in big picture sense, this is the classic crystalline core of the North Cascades, which means that this is the stuff that was 20 miles below the surface of the earth, and all of these swirls and patterns, all these stripes and squiggles and minerals are recording the time when these rocks were deeper than 15 miles below the surface of the earth. And then you may recall, and we'll revisit it again with our new live stream series this winter, you may recall that I was most interested in why this stuff all came back up. Like, why isn't this stuff still way down there? And why did it come up so rapidly? To me, that's the most interesting story. But in a basic way, what we're looking at are beautifully banded metamorphic gneisses, and those are not super common to find. And yet here, it's pretty much every rock that you pick up. And just as I'm doing this with you, I'm reminding myself that there were different kinds of gneisses that Stacia Gordon in particular was being careful to enunciate. We have an ortho gneiss, which I seem to remember means it used to be a magma that has been, is that right? Ortho gneiss and banded gneiss, is that the same thing? I forget. The gneisses that I'm trying to think of what Bob and Stacia kept talking about when we were hiking. If you saw that Dream Team video this summer, and we were hiking and collecting samples of that's the same Skagit that we're looking at here, the same Skagit metamorphic gneiss. But Bob and Stacia were talking about, it's an age-old question. Are we looking at gneiss that used to be Arcosic sandstone here? Or are we looking at metamorphic gneiss that used to be a granite, and then the granite has been smeared out and kind of segregated into these black and white bands? And apparently it's not an easy, well, not apparently. According to those guys, it's just not obvious when you're out in the field. Whether you're looking at I'll just, because I can't remember the terms, I'll just say gneiss that used to be sandstone versus gneiss that used to be granite. God, boy, oh boy. I mean, this is worth a stop. When there's only room for a couple of cars to safely pull off here, and it's not a formal pull-out spot. But man, oh man, if you can do it safely, gosh dang. And I'm guessing that they were pretty heavy with the dynamite here as well back in the 1970s to squeeze this road in here, but thanks to those guys for their work. I'm just going to keep it rolling. Traffic's pretty light for an afternoon here. Oh, I guess this is some of this pegmatite stuff. Is that true? He asks himself. The minerals are so white here that it's kind of difficult to see that the minerals are extra large, but I think that's what they're talking about. I have to get out of the road here. Oh yeah, this stuff's wild. Look at this. This looks like I don't know what it looks like. This looks like vanilla bark. You remember the candy bark? Like almond bark? I think there was some, oh maybe that's what it was, almond bark. I think I ate a whole tin in one sitting as a 9-year-old, and I'll let you finish the story. What a maroon. A lot of dark kind of staining here to kind of conceal things, but yeah, some of these, again, I'm guessing, but I think this real white stuff is the pegmatite she was talking about. Marley now I'm talking about. Maybe Daryl. God dang. Okay, no traffic noise. Coming back out for a second. Oh no, I'm not. I want to come over and see the falls. I think I can skinny right in here. Ironically. So much good stuff that's just right next to the road that most people zip right on by. Yeah, let's just peek over here. Looks like I'm not the first that had the idea. This Skagit Gneiss is a major deal. If you look at a map of the North Cascades, there's just so much that is Skagit Gneiss. So it's not an accident that Stacia and Bob and many others have been trying to learn as much as possible from these outcrops. And in the case of Stacia and Bob and those two grad students that you met this summer, they needed to get up into the backcountry to get access to more of this. Oh, wow. Why is it so weathered over here? Are we just kind of in the shade? Is it an aspect thing? Does it stay moist most of the year because it's usually under snow for much of the winter? Maybe much of the year? Huh. Beautiful. Well, the sound of the waterfall is tempting, but it's very steep over there, so I'm not going to risk it. 20 years ago, I would have been more bold, but I'm a little wimpy now. I know my limitations, I guess. Yeah, I mean, it's one thing to see metamorphic gneiss in a little box in a laboratory. If you take a petrology class or even a geology 101 class, and even then, I mean, I think it stands out. It's like, wow, are there really rocks like this up in the mountains that are like stripy like this? But then if you actually come out to these places and see it in its natural setting, I gotta say, it's even more impressive. To me. I mean, come on, this isn't Craters of the Moon. Nothing's Craters of the Moon. Nothing matches the sheer power of Craters of the Moon. Inside joke. It's tough to be blasé about the North Cascades. Quiet, popping out like a boss. Well, I get the feeling a lot of geology classes have been here over the years. Otherwise, why would all the best samples be just right here at this little altar? Keep it going, boy. Keep it going, boy. I want to see hand samples, boy. Boy, it's difficult to hold this one up. This is kind of interesting. It's not wet. It looks wet. Why is that so shiny and groovy like that? Literally groovy. Is this granite? Huh. Yeah, I don't know. Do you have a favorite? Okay, Skagit Gneiss, near Diablo Lake. Thanks for watching. On to the next.